derivative respect to x, respect to y, or respect to z. Okay, here's the deal. Okay, number 4, number 5, number 6. It's basically the same. Okay, so let me just do two of them between number 4, 5, 6. Okay, what do you suggest? Which one do you want? I suggest we try one is number 5 because number 5 is a little bit difficult. Not very difficult because we have quotient rule inside. Okay, for number 5. And between number 4 and number 6, which one do you want? Or you still want all?
Number 4.
Can all, Doctor? Mana-mana lah.
Okay, no problem lah. So your function is 2 x y 5 ln z plus z e power of y divided by x. Okay, now first they ask about the partial derivative respect to x. Okay, so partial derivative of f respect to x will be, okay, differentiate respect to f. What will I get for the first term? For this one, what will I get?
Two y to the power of 5 ln z
Okay, correct.
plus
So
z e y
2y5 ln z, because we differentiate respect to x. Okay, this one.
plus z exponential to the power of 5.
Are you sure plus?
Is it not? Is it negative ke?
This one you can also rewrite as z e y x power of -1.
If I do it like
Or you do at the back, no problem. If you want to do like this, z
okay.
e y negative like this, x power of
Negative 2.
-2.
Itulah.
Correct, -2. Correct. So at the end you need to multiply. Still you need to multiply. Simplify will be 2y5 ln z minus z e y over paham? Hello? Hello, guys? The questions asking you not only this, but they ask you the partial derivative of f respect to x when the value of x, y, z is 2, 3, 1. 2, 3, 1. Okay, substitute the value 2, 3, 1. X substitute into 2, y 3, z 1. Give me the number. What you will get? Just substitute the value. No need to write down. I don't need to write down. I think you can just substitute the value. Very simple. Give me the number. Anyone? Guys, are you doing
2
this?
times 3 to the power of 5.
Okay, the final number, final answer.
Oh, okay.
Final answer. Just do it now. It's okay, take your time. Just
Negative.
Negative?
Negative exponent power of 3 e power 3 over 4.
Approximately, you use calculator? Just the number, the decimal number, approximately. E power of 3 will be what? Use calculator.
5.012.
Negative 5.021.
Negative 5.
Negative 5.0.
5.02.
Okay. Negative 5.02.
0, yeah.
214. Your friend also write down Azlin Arisha. 214. It's okay lah. 102 also no problem. Okay. Good. Yes.
Betul?
Yes.
Memang tak boleh tukar listing apa ni exponent lah. Kena
No, no
find.
need, no need. If you want to write down in exponent form, also no problem. If you write down in exponent form, this one should be z two so 2 multiple with 3 power of 5. Why 3 power of 5? 2 times with 3 power of 5 learn. Oh, this one is 0 because 0 learn 1 is 0, so this one is 0, no need. So just negative z1 e cube over x squared 4 like this, yeah.
Yes, yes.
Yes, no problem. You can write down this one also, no problem. Okay, paham? You can write down negative e cube over 4, no problem. Or you can write down approximately negative 5.02. Okay, so now give me the partial derivative of f respect to y. What will I get?
10x y to the power of 4
Then x, y, 4 ln z.
plus yz. Minus juga. Tak.
Differentiate respect to y. Here.
Yz
Differentiate
exponent
respect to
y
Hmm?
over x.
Z-E-Y over X.
Z e y over x, still the same. It is the same like this. If y equals with 3e power of x, y prime still 3e power of x. You get the idea, okay? So the 3 is the same like z over x for our case in here. No problem?
Okay.
Okay. Now give me again the partial derivative of f respect to y this time still. When 2, 3, 1, what is the answer will be? I think I see this one. Negative e cube over 2. So approximately around
Positive brother.
sorry,
Positive.
positive. Oh yeah. Oh yeah, positive. My mistake. Positive. So 10 point something, yeah?
3 point
10.04.
something.
10.
I silap. Sorry. Yeah, 10. 10.04.
10.04. Betul? Guys? Do you have any problem? Hello? Hello?
Okay.
Yeah. Now, last for number 4, they're asking about the partial derivative f respect to z equals with. You want to see the equation again? Yeah. The problem is you don't have any tablet like me. Yeah? If you have tablet like me, we can do like collaboration. You can write down here. So you can make annotation. I prepare the whiteboard. I can use another software maybe, but no problem lah. Okay, so respect to z, what is the partial derivative?
2xy
2xy,
the power of 4 over z.
2xy 5, not 4,
5, yeah.
over z,
It doesn't say
correct?
4, sorry. Plus
Plus
ey over x.
ey over x, correct? So again, they're asking about the partial derivative of f respect to z when 2, 3, 1 equals with. I think approximately you just put the number lah. This one approximately. The decimal number will be
982.04.
982, 982.04. Please check.
Betul tak orang lain? Dapat betul, sama tak?
I don't know. I don't know.
Betul.
Same, same, same.
Okay, so yeah.
Thank
Okay,
you.
good. Do you have any problem for this one? Hello, do you have any problem?
No,
Do you have any
faham,
question
faham.
for this one?
All good.
Okay, yeah. This one okay, yeah. So
Okay.
okay, good. So now, here for number 5.
Doctor,
Okay,
should we be adding all of it or just say it this way?
add all of what? What do you mean?
The number
Oh, you mean
number negative 5 semua tu.
no,
Tak
no, no,
nak
no, no,
nama.
no, 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 no.
Okay.
No, they're just asking individually. Okay, so for every one of the questions, we'll give you different marks. So for this question, for example, for the first one, the partial derivative respect to x, like the -5, you will get like 4 marks, and then the second one you will also get the 4 marks, and then the next one you also get 4 marks. That's it. Something like that. Okay.
Okay.
Okay. Wait.
Okay.
Okay, now number 5. Now, if you see your questions at number 5, okay, let me just modify the questions a little bit because it will make you it's okay if you want to modify it, okay? They just want to get you confused. The question is actually like this. Sorry, let me do in black color. F equals with 2u over u plus 3v. Okay, this one later you gonna need quotient rule. Quotient rule, this one will be u, this one will be v. So we already have u in here, we already have v in here. So I think we can get confused with the uv later in the quotient rule. Okay, what I mean is if you see these questions, they want to make you confused, you can you can make the similar questions. Let's just say f, I just change into 2x divided by x plus 3y. It's the same thing. Okay. The one that they ask is they ask the partial derivative of, oh, that one is w. Yeah, my mistake. This one is w. Okay. They're not asking this. This is not f, but this is w. Okay. They're asking about the partial derivative of w respect to u, which this is the same that we will calculate partial derivative w respect to x, and then they're asking about the partial derivative of w respect to v, which is the same with partial derivative respect to y. Okay, so should we do this? Up to you. You want to do it or not? Okay. For me, I prefer to do it because I already very convenient with the terms of u divided by v, u prime v minus u v prime divided by v square. So if I have u v again, it will make me confused. So I prefer to use this one, w. Okay. You understand what I mean?
Faham, faham.
Yeah, no problem. Yeah. Okay, now we want to differentiate. The first one is the partial derivative w respect to x. Okay, if you see here, for both sides, for the numerator we have x, for the denominator we also have x. So this kind of thing we need to do the quotient rule. The first one you consider as u, the denominator consider as v. So u equals with 2x. U prime for this case is u differentiate respect to x because we want to differentiate respect to x here. Okay, so u prime will be
2.
2, v equals with x plus 3y. V prime for this case again v respect to x equals with
1 plus 3y.
no
One.
3y consider
only.
as 1 only, 3y
Sorry.
consider as constant, so the derivative just 1 only. Okay, this kind of things you have to do a lot of exercise. Okay, I know you just not get used
How
with
do you determine that it is respected to x?
Okay. Here, because we differentiate respect to x here, we want to find this.
Okay.
So if you want to use the quotient rule u prime v, u p v prime, or the product rule, you need to differentiate respect to x. Okay, depends on the problem. For our case, this one we differentiate respect to x, so it will be respect to x. So the partial derivative of w respect to x will be u prime v minus u v prime divided by v square. Okay, substitute the value, just simply substitute the value u prime 2 v x plus 3y minus u 2x v prime 1 divided by x plus 3y square. Okay, so 2x plus 6y minus 2x divided by x plus 3y square. Okay, so cancel 2x with 2x. I will get just 6y divided by x plus 3y square. The question is not only this, but the question is when 1 2. Okay, the question is the partial derivative of w respect to x. Okay, in our case, for our question is actually respect to u 1 2. Okay, give me the number. 6 over 7. 6 over 49. Sorry, 12 over 49. Hello? Hello? Guys? Hello? Are you still there?
Hello.
Still there?
Yeah, yeah.
Yes, yes.
Paham 12 over 49? That one is correct or not? I think correct.
Correct. Laju better.
Okay. Now, let me write down again the function. Now we want to differentiate respect to respect to y. Let me write down again the w, so no need to go back and forth. 2x, x plus 3y. 2x divided by x plus 3y. Okay, now we want to find the partial derivative of w respect to y. What should I do? What should I do?
Differentiate with respect to y.
Okay, so what is the result? Is there any rules that I need to use? Any properties?
Quotient rule.
Quotient rule again? No need.
Mhm.
No need. Why
No need.
quotient rule? Okay, why we use quotient rule here? For
Sebab
the
dia bahagi.
first place. No, sebab because we want to differentiate respect to x here. The denominator, the numerator consists of x here. The denominator also consists of x. So we differentiate. So we need to do the quotient rule. Okay, function divide by function. This one, we want to differentiate respect to y. Is
Y.
there any y in here?
No.
So this one can consider as constant.
Constant.
It is the same like 1 divided by, let's just say 1 plus 3y. Something like this. This is just constant, the x.
Mhm.
Okay, paham? So no
This
need to
3.
do. So it is the same. You can write down 2x multiple with x plus 3y power of negative y. Okay, the result will be, remember this one? If I give you a hint like this, y equals with, let's just say 7 multiple with 3x plus 2 power of 4. What is the first derivative? Y prime? Still remember? Anyone? 7 multiple with the power here 4 and then multiple with the derivative of this. What is the derivative of 3x plus 2? Just 3. And then multiple the same thing 3x plus 2 power of 3 or minus 1. Anyone remember this? Hello? Chain rule from last semester, not from this semester.
Yes.
Anyone remember it?
Yes.
Yes. If you forgot, check again your lecture notes from last semester. 7, 3, 12, 7, 84. 3x plus 2 power of 3. Okay, same principle. What will I get in here? For this one, the same principle for this one.
-2.
Let me do it manually. Yeah, I know you already know. So 2x first. And then the -1 going down, multiple with -1. Correct. And then the derivative of the one inside, the derivative of this. The derivative of x plus 3y. Respect to y, what is the derivative?
S plus 3.
No, differentiate respect to y.
3.
3
3.
only. 3 only. And then everything x plus 3y power of -2.
2.
Paham? So it will just give me -6x divided by x plus 3y square. Paham tak? Do you understand? Hello? It's okay, take your time, but do you understand or not? At least you can tell.
Faham, faham.
Get apa ya? Partial derivative respect to y, yes, paham. When the value is 1, 2, simply you just substitute the value, no problem lah. 1, 2, -12 divided by 49. Okay. Hello. Do you have any questions?
Okay.
Negative 6 tak?
Sorry?
Negative 6.
Huh?
Negative 6 over 49.
Negative?
2.
-12, right? Over 49? Oh, x. -6. Yes. Very sorry. 6. -6 over 49. Correct. Betul. My mistake. I'm very sorry. Okay. The Koi machine here is broken, so I drink cold coffee. It's not good, cold coffee. I need hot coffee. Okay. Do you have any questions? Do you understand?
Yes.
Yes. Okay, good. Now, 6. G equals with x e y square tangent x square plus y. Okay, now you need to find the partial derivative of g respect to x. Okay, what should we do?
Product rule.
Product rule. Okay, what is the first? All of this, because we differentiate respect to x, all of this can be considered as u. All of this, the tangent, can be considered as v. Okay, so the u is x e y square. U prime, again, for this case, is respect to x because we want to find the partial derivative of g respect to x, which is ux will be
1.
No,
EY.
EY square
EY
only.
square.
The EY square, not 1. EY square, look at this EY square, the constant. Okay, the V. V equals with tangent x square plus y. Okay, next time if you see this kind of questions, okay, if you confused about the tangent, everything, you prepare yourself, okay, with the formula. You can simply just Google WebEx. Okay, let's just say differential table. Just Google, prepare by yourself, okay. There's a lot of differential table, so let's see one at a time. How about this one? No, how about this one? Here, do we have tangent or this one tangent hyperbolic? Here, do we have tangent? No, I don't see any tangent. Is there any tangent? I need to see tangent. Is there any tangent integral? Here, tangent. Can you see this? Where is the table? Here, tangent. Okay. The derivative of tangent will be secant square. Okay, the derivative of tangent will be secant square. So here the v prime will be secant square of x square plus y. Differentiate respect to x, so you need to differentiate this respect to x. So what is the derivative of x square plus y?
2x.
Okay, let me write down here lah. Okay, let me write down again. Okay, so v prime equals with secant, or in this case v respect to x, because differentiate respect to x, secant square x square plus y. Your friend already say multiple with 2x. The derivative of this respect to x. This one is chain rule. Okay, so just 2x secant square of x square plus y. That's it. Okay, if you see like some unusual differential or unusual integration, normally we have differential of sine x, cos x, and then suddenly you see tangent x, suddenly you see like something else lah, secant x. What is the derivative of secant x? That one is difficult. You just find the table. Okay, prepare yourself with a table of integration and table. You just search the keyword for Google. In Google is table of differential or table of the derivative. You can find the keyword like that. Okay, so now based on this, the derivative u prime v plus u v prime. Okay, I simply substitute the value. U prime is e power of y square. V is tangent x square plus y. Plus u x e y square v prime 2x secant square x square plus y. So it will be e power of y square tangent x square plus y plus 2x square e y square secant square x plus y. Do you have any problem? Do you have any problem? Or okay, yeah. So far you can catch up, yeah. You can follow, yeah. Now this one, if we want to find the first derivative respect to y, now again we still need to do the chain rule. Why? Because this part consists of y, which is y square, so you can use this as u. This part also consists of y. This one will be v. Okay, let me just continue directly with the GY. So for the U,
Chain rule or product rule?
product rule, because this one have Y multiple with this one.
Alright.
Function, multiple with function, both of them have Y because we want to differentiate respect to Y here. Both of them have Y, so product rule. Okay. Now, the U is X E Y square. U prime, for this case, U respect to Y, again, because we want to differentiate respect to Y, will be equals to
XEY squared.
multiple with the derivative of Y square. That one is chain rule,
2y.
2Y. So it will be 2XYEY square. Okay. V equals with tangent x square plus y. Okay, so v prime in this case is v respect to y will be the derivative of tangent will be secant square x square plus y. Okay, multiple with the derivative of this respect to y will be the derivative of x square plus y.
1.
So it will be multiple with 1 only actually, yeah. So you just second lah. Second square x square plus y square. Okay, you do it by yourself. So just gy, I can skip, yeah. Just u prime v plus u v prime. Just simply substitute u prime and v prime and so on. Paham? Hello?
Paham.
Paham ya? Do you have any questions? No problem? Hello?
2y squared ke? Secant squared x squared plus y squared ke ataupun
Who write down y square? It should be bracket.
sorry. Alright.
It's not me, somebody else. Nobody can blame me. If somebody come to my office and then suddenly, you cannot see, right? There's somebody in my office, maybe they write down the y square. Not me. Okay, do you have any problem now? No problem, yeah? Okay, so, just like this, everything simple like this. Only the question is too simple. Why? Let me do it in black. W equals with 2x y square e z plus 4 sine x square plus y square plus z square. Okay, wx equals with guys. Hello, are you still there? Anyone?
Yes, sir.
Okay, wx
Z y squared e
not z.
z.
This one is 2. This one is 2.
Oh, two. Oh, okay.
2 y square e z. Okay, correct. And then
Plus.
plus a. What oh, you want to do that like that directly? Let let's just do manually first, okay? It is 8 later. So 4, the derivative of sine will be just cos x square plus y square plus z square. And then you need to multiply the derivative of this respect to x. The derivative of this respect to x will be
QN.
Two.
QN.
2x.
Betul.
That's why you get
bukan,
8.
bukan cube ke semua?
Oh, cube ya? Oh, who write down square?
Cute.
Somebody come to my office suddenly, seriously. Cube. Cube.
The ghost.
Cube.
The ghost.
Goose, maybe. The goose, yeah. Now the goose at home now. 3x square, yeah? Okay. So 2y square z. Oh, sorry. E z plus 12x square cos x cube plus y cube plus z cube. Okay. Do you have any problem?
Oh.
No. Okay. Now w x x equals with. They're asking about w x x.
2y.
Respect to x. Differentiate this respect to x. What you will get? Focus on this. We want to differentiate this one. Respect to x, what we will get?
Wine.
Hmm. Hmm.
1.
Hmm.
Mana?
36.
Differentiate with respect to x.
That
Zero.
will jadi 0.
Zero. I hear somebody say
Zero.
0. This one is 0 because there's no x in here.
Oh.
Everything is considered as constant. So the derivative of constant 0. Oh, paham?
Okay.
Faham.
Okay, good. Now plus for the second part, okay, the second part there's 2x. This one consists of x. This one also consists of x. So you need u prime again. U multiple with v. Okay, so u equals with 12x squared. U prime in this case, u respect to x will be 24x. The simple one, I just do it directly, yeah, because it's very simple. V equals with cos x cube plus y cube plus z cube. So v prime in this case, v respect to x will be
Negative sign.
negative sine x cube plus y cube plus z cube. And then
Time 3x.
Yes, X
x.
square.
Correct. So negative 3x sine x cube plus y cube plus z cube. No problem?
Good.
Good. So this one is u prime v plus u v prime. So it will give me result u prime 24x v cos x cube plus y cube plus z cube plus u 12x squared v prime negative 3x squared sine x cube plus y cube plus z cube. Okay, so 24x cos x cube plus y cube plus z cube minus 12 multiple with 3, 36, x squared with x squared, x power of 4 sine x cube plus y cube plus z cube. Done. Just like that. Simple. I think.
Oh.
Paham? Okay, this kind of thing, you just simply need exercise. Just do a lot of exercise. Okay.
Need
No problem.
exercise and answer.
Let exercise and answer and the solution Okay, let me ask do we have the solution? Let me ask. Okay, I already asked. If they reply, I will ask. I will inform to you. Okay, now. See, the internet connection in here is not good. Sketch. Okay, number. Now we go to number. Can you do the Y, Z, Z, and Y, W, Y, Y, and W, Z, Z by yourself? Hello?
Yes, yes.
It applies all the same principles, right?
Everything is the same. Everything is the same principle.
Okay.
W,
Then I
Y,
think should be
Y,
no problem.
and W, Z, Z. You do it by yourself. Okay?
Okay.
Everything is the same principle. Okay? Just follow the step. Just keep in mind you differentiate uh okay. Okay. So number 9. Everything is the same principle. We go to number 9. Okay. Number 9, they tell you that why this? I don't want this. I need this. They give you information that u equals with x squared y squared over x plus y, and then show that x ux plus y uy equals with 3u. Okay, you need to show this one. Okay, so in order to show, I think we need to find this one, the derivative of u respect to x, and we need to find this one, the derivative of u respect to y, and then we multiply. We do the equation. Is it correct? The left side, is it the same with the right side? That's what we need to do. Okay, just follow the flow lah. Just follow the flow. The flow is like that, so you just follow the flow. Later it will give you something. Now the first thing that I need to do is I need to find the ux. Okay, I need to find ux. So is there any rule should I use for this one? First question is there any rule that I need to use for this one?
Question rule.
Quotient rule. Okay, let me change the questions again. Why we need to use quotient rule?
Because the
both
numerator have
is
x.
numerator and denominator.
But because the numerator have x and the denominator also have x, and we want to differentiate this into x. Okay. Oh, they put u yeah. Okay, let me change lah. You make me confused because later I need to use u. Let me change this one into f lah. F fx fy 3f. So I need fx. So for the fx, let me just do the fx. Let me do in red color. Fx. So I need u and I need so v. So what is u? X squared y squared. What is u prime?
2.
2x y square.
X, y square, correct. V is X plus Y. So what is V prime? One. I hear somebody say one. One only. Differentiate respect to X, yeah? U prime V minus U V prime divided by V square. U prime 2xy square multiple with V x plus Y minus U x square Y square multiple with V prime 1. All of them divided by x plus Y square. Okay. So let me simplify a little bit. So this one will be 2x square y square plus 2xy cube minus x square y square. Is it correct? Divided by x plus y square. Okay, so I will get x square y square plus 2xy cube divided by x plus y square. Done. Settle. Fx. Okay, no problem.
Okay.
Okay. Can you find Fy? Just give me this final answer. Fy. I think we also need the quotient rule. Just give me in this form only. You already simplify. You understand what you need to do?
Same question rule. Quotient.
Okay, so like this, you just give me the final answer, the one that in the blue box.
X2 Y
X square y.
Y square.
Can you check again? Can you double check? Double check lah. X square y square already. You already calculate. I know the final answer will be. Wait, yeah. I know the final answer will be x plus y divided by sorry square. This one will be the denominator will be like this. The numerator
2x
Two.
cube y
2x cube y
plus x square y square.
x square y square. Okay, please check again. I need at least 2% can confirm that this is the answer. Then we proceed from here. Is this correct?
Yeah, same.
Same. Are you sure? Same. You already do also.
Okay.
Same.
The
Okay.
blue one.
Okay, I trust you. Okay. Okay, no problem. Can you confirm this is the answer? Yes. Hello. Clear, guys.
Yeah.
Okay. So now I need to the question show need to show that x fx plus y fy equals with 3f. Okay, you just substitute x multiple with fx. What is fx? X square y square plus 2xy cube divided by x plus y square plus y multiple with 2x cubed y plus x squared y squared divided by x plus y squared. This supposed to be equals with 3 multiple with f. What is the f? X squared y squared, x plus y. X squared y squared divided by x plus y. Okay, this is what we need to do. You just simplify this, check whether the left side equals with the right side. Okay, if I simplify the left side, the denominator both have x plus y squared, x plus y squared. Both of them is the same denominator. So let me just put in the long single form like this, both x plus y squared. Okay, x multiple with this, I will get x cubed y squared. X multiple with this, I will get plus 2x squared y cubed. Y multiple with this, I will get plus 2x cubed y squared. Y multiple with this, plus x squared y cubed. This is supposed to be 3x squared y squared over x plus y. Are you still with me? Do you understand? Hello?
Yes, sir.
Yes.
Still me, yeah? Okay, now let me do the operation that is the same. X cubed y squared, 2x cubed y squared. It will be 3x cubed y squared. X squared y cubed 2, x squared y cubed 1. So will be plus 3x squared y cubed divided by x plus y squared. Nothing changed on the right side, still the same. Hello? Hello? Guys?
Yes.
So what can we do next for the left side? I can take out the x squared y 3x squared y squared. If I take out from here 3x squared y squared, it will leave me only x. Betul? If I take out from
Betul.
here 3x squared y squared, I just leave me only with y only. Correct?
Yep.
Divided by
Yes.
x plus y squared. I can cancel x plus y, cancel with this. So it will leave me only with 3x squared y squared over x plus y, which is this exactly the same with 3x squared y squared over x plus y. Here, exactly the same with this. 3x squared y squared over x plus y, 3x squared y squared over x plus y. This is what we do. So we already show that x fx plus y fy equals with uh, 3f. Paham?
Paham.
Faham.
Paham ya? So this is how you show. If the question is asking you, show that this one equals with this, or you have to do it. Just follow the flow. Oh, they have fx. Okay, I need to find the fx. They have fy. Oh, I need to find the fy. Oh, and then after that, they multiply. X multiply with fx. Oh, we just multiply x with fx. Y multiply with fy. Just do everything. At the end, you will get the result. The same result. Okay. Sketch again. Okay, now the next one. Do you have any questions with this? Hello?
Okay, good. So far, so good.
So far, so good. Okay. Number 10. Okay. So we have W is a function of 2, which is 3. Function of R, function of S, and V. The value inside is R square minus S cos V. Okay, and then I have R is the function of T, which is R equals with E power 3T. S is a function of T only, which is S equals with sine T. And V also a function of T only, which is equals with 2T. Okay, the question is, they want to know the derivative of W respect to T when T equals with 0. Okay, this is the question. Okay, this is how to understand now. If we look at this, if we look at the questions, okay, can I continue or you want to is it okay if I continue?
Yeah, yeah.
Okay, so the questions asking you, we need to find the first derivative of W here respect to T. Okay, but in our questions, okay, in the questions, the W do not have any T. Okay, what we can do from the W, you can find three first derivative. The first one is the first derivative of W respect to X, or you can write down as, let me just in the partial form, partial W respect to R. You can find the partial derivative of W respect to S, and I can find the partial derivative of W respect to V. But I cannot find the W dt, this one. Okay, so this when we use later chain rule. Now, before we use chain rule, normally, again, just follow the flow. We need to find all the first derivative first. Okay, so respect to R, what will I get? The first derivative of W respect to R?
2R.
2R.
Only, correct. To R. The first derivative of W respect to S?
Negative cos B.
Negative cos V, correct. The first derivative respect to V?
Negative S sine V.
The derivative of cos is negative sign. So we will be positive.
Oh, S sine V.
S sine V, correct. S sine V, okay. This simple thing, okay, the derivative of cos, the derivative of sine, if you cannot memorize, again, I told you, just take just prepare with the formula, okay, the derivative table. You can just Google. There's a lot of derivative table and integration table, okay, no problem. Again, I strongly suggest you refer to your table that you can get later, okay. I know the derivative of sine will be cos because I already do this for more than 10 years. For me, I always do this kind of thing more than 10 years. So it like already stuck in my mind. For you, you just study for, yeah, for your subject only lah. Okay, not for your life. This is my life, so I already remember everything. For you, I strongly suggest prepare with the derivative table and the integration table. Okay, no problem. Just refer to the table. Okay. Now, for the R, okay, I can find for this one. I can find the derivative of R respect to T only, which is equals with
For you, Doctor?
3E 3T. This one. Are you talking to me?
Okay. Yeah.
Okay. Now the S, the derivative of S, only one variable, so we can find the derivative of S respect to T only, which is equals with
Cos T.
cos T, correct? Simple. For this one also, I can only find the derivative of V respect to T only because only one variable. So it will be why not confident? Two. Okay. So that's it. That's what we do. Okay. Please, if you can do, please, if you can, whenever, especially after this, if you maybe you take master, if you take master degree, or maybe you want to take PhD, something like that. Okay. This very notation is very important. Look, the W, remember, look at this. W have three variable, R, S, V. When I find the first derivative, I'm not writing D, but I'm writing delta W, delta L. Okay, delta W, delta S, delta W, delta V. For the R, if you refer to the R only one variable. So when the first derivative, I'm writing as dr dt. I'm not writing as, this one is not correct. Partial derivative of R respect to T. No, this one is not correct. Okay, this one for more than one variable. For the R, only one variable. Okay,
If R
this
prime, sir?
no problem. If you want to write down R prime, also no problem. Okay, R prime also no problem. For W, if you want to write W prime, it's not appropriate. It will be better if you write down WX or WY or WZ. Can we write down W prime? Yes, but not appropriate. It will be better if you write WX, WY, WZ. For R, yes, we can write R prime, S prime, V prime, no problem. Okay. Notation is very important. If you can read notation, it is simple for you to take your PhD or your master degree if you want to continue. Okay, now, again, let's just follow the flow. The questions asking you about dw dt. Okay, I don't have dw dt. For the derivative of w, I have these three derivative, which is w respect to r. I have partial derivative w respect to s, and I have partial derivative w respect to not t, v respect to v. I have these three. Okay, now how can I change this into the r? I change into the t. That's the problem. Okay, I have this dr dt. That's when we use chain rule. This one, if I multiply with dr dt, actually it's not cancel. Yeah, please. The simple way to understand, cancel dr with dr, I get dw dt. Okay, but actually it's not cancelled. It means differentiating r with respect to r. Okay, that will be 1. Differentiating r with respect to r will be 1. Plus, I want to remove ds, delta s. So multiple with ds, dr. Sorry, what r? dt. Plus, I want to remove the v, dv, dt. This is what we know. Again, we already studied this about. This is called multi-variable chain rule. Okay, just follow lah. Follow whatever you get. Normally you will go to somewhere. Okay, W R to R, dr dt, 3e 3t, 3e 3t plus ws negative cos v, negative cos v, st cos t plus dw dv s S sine V dv dt 2. Okay, so it will leave me only with 2 times with 3 will be 6. The value of R, let me substitute. You need to substitute the value of R, yeah? Everything put in the T form. This is R. E power of 3t. So the R I substitute with e power of 3t, e power of 3t. Negative cos V. Substitute the V. V is 2t. So 2t cos t. Wait, yeah. Okay. And then plus S. S. What is S? S. 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 Sin t. What is this? Oh, sorry, you have 2 in here. So let me put the 2 in front. 2. S is sin t. V. V is 2t. So sin 2t. That's it. Paham? Hello?
Just like that.
Just like that. What do you want? You want something more difficult? Oh,
No,
yes. We still can
50.
simplify. No, we still can simplify a little bit. We can still simplify a little bit. This one, E3T, E3T will be E3T, E3T.
Uh,
60. 6 is
E9,
6, not 9. 6 plus e power of a multiple with e power of b, a plus b. So plus 3t plus 3t, 60. Minus cos 2t cos t plus 2 sin t sin 2t. That's it. Paham?
okay.
Okay. Okay. So let me ask you, do you get the flow lah? Do you get the flow of doing this? They give you W,
Yes.
they give you the R, they give you the S, they give you the V. Okay, they asking about dw dt. If you look at your function, W do not have T at all, but we can find the first derivative respect to R, S, V, and then from all of that, yeah, the one that I remind you that like the easy one, you can say that cancel, so you get W dt, you cancel W dt, cancel W dt, so everything just lead you to the dw dt. So that one is called multi-variable chain rule. After that, you just substitute the value. Don't forget, if you substitute the value, you put everything in the terms of t, because this one is t. Okay. Now they ask not this one only, they ask when t equals to 0. My mistake. My mistake. Yeah, your friend also, I think your friend already know, but I just forgot to see this one. T equals to 0. Okay, substitute 0. 6 minus cos 0, cos 0 plus 2 sine 0, sine 0. Sine 0 is 0, cos 0 is 1, so 6 minus 1, 5. 1. Not like that. 0. So 6 minus 1, 5. Okay, this is the final answer. This is the correct one. That's it. Hello? If you forgot this, maybe you will lose like 2 marks only to substitute the value of t. Okay, so don't forget.
Okay,
Paham?
slowly.
Paham?
Faham.
Okay, for I just want to give you information. These questions, the chain rule, this one, the multi-variable chain rule will not include for tomorrow test, for tomorrow quiz. Okay, tomorrow quiz until like the second derivative, like f f x f f y f y y f z z, something like that. Maybe the third derivative x x y x x x x y x, something like that. Okay, the partial, sorry, the multivariable will not include. This will be included for the assignment and the final. Okay,
Chapter 2 only, eh?
chapter 2 only for the quiz tomorrow, but not this one. This one is 2.5 if I'm not mistaken. This is chapter 2.5, yeah. So until 2.4 only.
2.6 until
Oh, this one
2.5 lah.
2.6. So until 2.5 then. Yes.
Oh, right.
Okay, right? So, okay. Ah, the same thing. 11, the same thing. 12, the same thing. 11 is the same thing, exactly the same thing. Exactly the same thing. Nothing changed. And then you substitute the value t equals with pi. Okay, no problem. Let me skip 11. 11 for your exercise. Okay.
Okay, skip.
It's exactly like this. Okay. Let me do 12. Okay. Now the 12, they get z is function of two variable u and v. The function is u cube plus v cube. Is it correct? Please correct me if I make mistake because
Yes, cube.
okay, because the picture is a little bit blurred. And then u is a function of two variable also, function of x and y. Okay, so the function is x y square, and v also is a function of two variable x and y. So it will be x square ln y. Okay, the questions that's asking two, the partial derivative of z respect to u, respect to x, and the partial derivative of z respect to y. Okay, if you see the difference here, the question asking you just dw dt here, dw dt. Okay, the derivative respect to t only. Okay, this one we use d. Okay, why? Because if we substitute r as v, your function will be the function of t only, t, t, t. Okay, so the derivative, the dw dt. That's why we put dw dt. Okay, now for this one, if I substitute u and I substitute v, I will get z became the function of x and y. So if I want to find the derivative, I will get partial derivative of z, not d, but delta z, delta x, and partial derivative of z, delta z, delta y. Okay, do you understand? Hello? Hello? Okay, guys?
Yes, sir.
Okay, good. Now, let me do one at a time. For this one, I can find two derivatives. The first one is the derivative of z respect to u equals with Hello? Hello?
3u
3u
squared.
square.
Correct. Correct. 3u squared. The first derivative of that respect to v. 3v square. 3v square. Correct, correct, betul. 3v square. Now, this one, let me do in blue. I have xy, so I have the first derivative of u respect to x equals
Uh,
Y
y square.
y square, betul. Correct. The first derivative of u respect to y equals with
2xy.
correct. 2xy. This one, the first derivative of v respect to x equals with
2x ln y.
correct. The first derivative of v respect to y equals with
X squared over Y.
correct. Now again, we just follow the question asking about z respect to x. Z, I have only z respect to u and z respect to v. Now I want to change u into x. I multiply with u x, and I want to change v to x, multiply with v x. Substitute the value. So zu will be 3u squared. Ux will be y squared. Zv will be 3v squared. Vx will be 2x ln y. Okay, don't forget after this you must substitute the value of u and v into xy. So 3 multiple with u is this xy squared. So xy square multiple with y square plus 3v. V is this x square ln y square multiple with 2x ln y. Okay, 3 x square y power of 4 multiple with y power of 2 y power of 6. 3 multiple with 2 6 x square 4 multiple with x power of 5 ln square multiple with ln y ln cube y. That's it. Paham?
faham. Dia macam sama macam tadi.
Sama. Everything is the same. All like this. Everything will be just like this. They just change. They will only change the variable. They will only change the function. Maybe they just make it more difficult. Instead of just x ln, maybe they change into second. Because second, you never see second, right? If you never see second, the derivative of second, refer to the table. The derivative of tangent, never see the derivative of tangent, refer to the table. Okay, just refer to the table. Everything that you find, if you is something unfamiliar, refer to the table. Okay, so one last, I think this will be the last, because number 13 and 14 again exactly the same, so I think this will be the last. Partial derivative of z respect to y, so we only have z respect to u and we only have z respect to v, so the u will be u y, v will be v y. plus, okay, ZU, 3U square, UY, 2XY, 2XY plus V, 3V square, X square Y, X square over Y, okay, so 3U, X, Y square multiple with 2XY plus 3V X square ln Y square multiple with X square over Y. Okay, so equals 3 times with 2, 6, X square multiple with X cube, Y square, Y power of 4 multiple with Y power of 5 plus 3, nothing else, X square, X power of 4 multiple with X square, X power of 6 ln square Y divided by Y. That's it. Oh.
Oh.
Paham?
Okay.
Take your time. If you think you make a line like this is what I do when I take my bachelor. I make line like this. Okay, when I have more understanding, the line become imaginary line. Okay, this is the line I already multiple first. Oh, X square, X square will be X square, and then I have X again. Okay, X square multiple with X, I will get X power of 3. Okay, I make this kind of line, no problem. In your notes, you make this kind of line, also no problem. Even in your final exam, if you want to make this kind of line, no problem. Okay, as when you grow better in mathematics, this line become imaginary line. For me, already imaginary line. Okay, it's already in my mind. Okay, if you want to do it manually, no problem. Okay, so do you have any questions so far?
Yang aspek tu ada markah
Yeah, if you simplify like this, at least 1 mark lah.
So kena buat lah.
If you do this, for example, if the total mark for this one, let's just say 10, if you arrive at this point, you already get like 8 maybe or 9. If you arrive at this is full mark 10. Okay. Oh, this one is 8 because you haven't substitute the U. You need to substitute U into this U. V also you need to substitute the V into this. Okay, so this one only 8. Substitute, you get 1 mark, and then simplify, you get 1 mark, so 10. For example, if the mark equals with 8 and 10, the full mark is 10. Faham ya?
Okay. Better than 0.
Better than 0. 8 already good. If you already get 8, already get A already. Okay, do you have any questions?
No.
No? If you don't have any more
Good
questions,
time.
I think that's all for today. Okay, you just prepare for your test tomorrow. Quiz tomorrow. I will give you detailed information about the quiz tomorrow because I need to discuss again with the other lecturers about the quiz. Okay. If you don't have any more questions, thank you very much. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Ta.
Thank you, sir.
Waalaikumsalam, sir.
Salam.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, Teh.
Thank you, sir.
Welcome.
Thank you, sir.